Class, welcome back to Stanford Code In Place. This is section 4. We spent the first section talking about Carol the robot and having him move around his world. Second section, we talked about program decomposition. Third section, we talked about console input and output. And now we get to enter the exciting world of graphics. And it is an exciting world, especially because this is a new graphics package that they just developed for us this year. And, I was looking at Chris's video and him talking about how he did graphics on this little computer with 3,584 bytes. And I know exactly which computer he's talking about. I started on the same one. It was a really fun program, a computer to do graphics on. And I think it's actually the best way for people to start out. Let's take a look at what's going on this week with our cheat sheet. So this week we're talking about graphics. Instead of taking some time to have people introduce each other, I'm actually going to tell a little story from the industry. I worked at Microsoft for many years, and I had the pleasure of dealing with Bill Gates several times. And I want to tell you about the time that I went to the Excel ship party, and this was at the fanciest place you could eat dinner in the Seattle area. And I don't mean the Space Needle, because this place is exclusive. Only members can dine there. So we go up to that place, and everyone in Excel is there. All the top brass of Microsoft Excel, as well as all the programmers, developers, testers. And I was, the new guy on the team. I was just first year there, and so me and my friends, we snagged the table at the back of the room and figured, this will be a nice place to watch without getting in the way much. And all the head brass were jockeying for position. So up at the front of the room, all the spots had been taken because they all wanted to be close to Bill. And so we still had a seat at our table, and this waiter comes up and he puts a plate of food down at this empty place. And I said, what's that food for? And the waiter says, oh, that's for Mr. Gates. And we're all looking at each other like, what did he just say? And sure enough, Bill Gates, because there's no place at the front of the room for him, he comes and he sits back at the very back of the room with us because there's a place to sit. So we have a great time talking to Bill during the dinner. And then after his speech and everything, then everybody came to our table because they wanted to grab Bill. When you worked at Microsoft, if you ever went to a big meeting and you wanted to know where Bill Gates was, you just look for the crowd of people. Wherever he was, there'd be like 5 people deep around Bill Gates. So anyways, that's a funny story that I tell. But believe it or not, that's not the only time that happened at Microsoft. It actually happened twice. And then actually a third time it backfired on me. I won't go into that story, but yeah, it happened a couple of times. And I've had the honor of dining with Bill a couple of other times as well. All right, let's talk about concept review this week. So graphics. It's kind of a shame that they actually, every time you do graphics, they actually give you these first 2 lines of graphics, because it kind of, I feel like unless you have to type it in yourself, you're not really going to learn it. So unfortunately, you can type it. I really do encourage you to type it in yourself. Everyone all gives it to you. But notice what it's saying, from graphics. What is graphics? Is that just something, can I just say from Kraken? Can I say from Microsoft? Can I say from Stanford? Well, you can actually say from Stanford. But no, graphics is a particular package that the Stanford Code In Place people wrote. And I actually saw a question by one of the students saying they tried to run this outside of our Stanford Code In Place IDE and it wouldn't work. And that's because this is not the standard graphics package available to the public. This is a special graphics package built on top of a public graphics package that's called Tkinter. So that's where this name comes from. It's only something special that's available in our environment. Import Canvas. Where does the name Canvas come from? Canvas is a name that the Stanford Code In Place people decided to call their package. And so now whenever you use, you invoke their package, as in the next line, you must use that name, Canvas. So here the second line is canvas equals canvas width height. Okay, now I think I didn't quite see this in the student forum. I saw something similar. So what is the difference between this name Canvas and this name Canvas? Well, one's got a capital and the other one doesn't, right? But really, the important thing is that this capital Canvas, the Python knows, because you've already imported Canvas with this capital, that this is what you're referring to. Okay, so if Stanford had written one called map, no, let's give it a different, my graphics. Okay, my graphics. Then what you would do is here you would use my graphics. Okay, whereas this word here, Canvas, it's complete coincidence that this is the same as this, even though it's got a different case. Okay, this could be foo, could be bar, could be jelly for all you care. Okay, it doesn't matter. They called it Canvas just because it is actually a canvas that's being returned. It's actually an object, which we haven't gotten into yet, but this Canvas package is building a thing, kind of like a very fancy toaster. Okay, you saw the analogy this week of a toaster. That's a function where you pass in the parameters like the slice of bread that goes in the toaster, and then the function will generate burnt toast. Okay, so the canvas by itself is actually generating an object that is going to be your drawing canvas. Its parameters are a width and a height. And, everybody's giving you these constant values like canvas underscore width, canvas underscore height. Okay, these can be just numbers. All right, they're just numbers. Okay, and then the third thing is I really want you to get into the habit of typing this: create rectangle and create oval. Okay, and again, why is there this canvas here? Does that come from this? No, it doesn't. This is canvas because that's the return variable that we got from here. Again, this could have been foo, and then this would be foo.create rectangle. Doesn't matter. It's just got to be the same variable. Another interesting thing that is not, I would say it's not typical. It's like half and half. Okay, some graphics packages do it this way, some don't. So notice they've got the X and the Y. A lot of graphics packages then ask for the width and the height. I personally do not like it when they actually ask for the right X or the second. So if I wanted a square starting at 100, 100, that's 100 wide and 100 deep, okay, I'd go 100, 100, 200, 200. Okay. The problem is that you can get confused about this. In fact, I did, as to whether am I providing the top left and then the width? You can get confused, and you can put these in, and it'll actually draw a rectangle backwards. And maybe I'll demonstrate that for you. But it will not draw an oval backwards. Okay, so somebody implemented rectangle and did it one way. Somebody else implemented oval and did it a different way. So I'll show you these things. So these are the functions that we're going to be dealing with a lot. Also, we're going to be dealing with parameters and return values. So here is a function, my function. Okay, so here's where I define my function. Starting this week, now you can provide parameters here and values that you pass in to these parameters. And somebody did ask the question for sure on the student forum saying, where does this P1 come from? I couldn't find where P1 is defined. And what is it? What relation is it to this variable up here? Because in their example, it was the same name up here as it was down there. Okay. So what happens is that this is actually the declaration for this variable. This variable only lives within the body of this function. There is no P1 up here. Okay. P1 only exists here. You can think of this as an assignment that looks like this. Imagine the first line is P1 equals value 1, okay? And P2 equals value 2. You can imagine that's what happens at the start of the function, because that is basically what's going on. So P1 and P2 are variables declared right here. They're only valid in here, and they receive the values of whatever you pass in up here. This name value 1, okay, that variable up there does not get modified if you pass it in as P1 and P1 gets modified here. No, value 1 doesn't change. This is a more advanced topic that is technically known as mutability, and It's a very interesting topic, and depending on languages like C versus Java versus Python, they treat it differently and very interestingly. But for now, just remember that this is a variable in the calling function, okay? It cannot be touched inside this function here. There's a different variable here that receives the value of that variable, and then it operates here locally. The only thing that can affect the caller is here when you return some result value. Again, this could be a variable, it could be a number, whatever. That can then affect the caller only because it can be assigned to something. And we'll do an example of that as well. Okay, so let's go and create some graphics and play with this a little. So let me go to let's go to your code. Let's click on New Graphics Project. Okay, I'm going to call this Test 4. And once again, they already give you all this from graphics import canvas, canvas width, canvas height, and then they create the canvas for you. I wish they didn't. I wish that you did it yourself, because otherwise it's really hard to learn this stuff, because you just look at it and you say, oh yeah, sure. If I actually asked you to go and create it yourself, then you would struggle because you haven't actually created it yourself. And that's why I really ask people, please write the code yourself. Okay, only when you write the code yourself do these brain cells connect with these brain cells and what's on the page. All right, so let's try creating some graphics here. So what were the two things that I talked to you about? Remember what they were? What were the two functions? Two functions were create rectangle and create oval. Okay, so can I just do create rectangle of, and let me just put in some dummy numbers here. Can I just do that? Let's see what happens. Oh man, look at all of this name error. Name create rectangle is not defined. So what this message means is that Python is looking for create rectangle and saying, is create rectangle, it should be a function because I see that he's got parens afterwards, but I didn't see a def create rectangle here. Well, what's wrong? Think about what I talked about earlier. Create rectangle is a method on this object canvas that is created up here. And in order to find create rectangle, you have to tell Python, oh, I need to do it on canvas, this canvas variable here, canvas.create rectangle. So now when I run it, it actually does do something. Now let's pay attention to these values here. So as I said, 0, 0, that's the start, the upper left. 100, 100. That's supposed to be the end. It doesn't look very square, does it? I'm just getting curious. What happens if I go to 300, 300? So what's happening here? What? So 300. I think I'm not seeing the full size of this. There we go. Okay, that's looking better. All right, so let's do 0, 0 to 100, 100. Okay, so if you look at the screen here, I'm trying to verify. So it's like 1, 2, 3, 4, right? So it's 1/4 of the screen width, 400, and so now let's start it at 100, 100. Now, think about what this is going to ask, right? So again, in a lot of graphics packages, ones I'm familiar with, 100, 100 would be the starting location, and 100, 100 would be the width, and it would look like this. But that is not what this drawing package does. It assumes that these two are the lower right. And so since I put it in the same, what's going to happen? I get nothing. Okay, what happens if I just make it a little bit bigger? 105, 105. Little teeny square. Okay, so that worked. Now, what happens if I did 25, 25? See, this is what I was telling you. It looks like it drew it perfectly fine, and we figured out, oh yeah, so I must have started at 100, 100. I'm guessing that's 100, 100, and that it's 25 by 25. I'm guessing it's 25 by 25, but that is not the case. Okay, we just proved earlier that this area here, this is a 100 by 100 square, the full outline. And what's actually doing is drawing it backwards from 100, 100 to 25, 25 up here. Interesting, huh? Okay, so let me demonstrate again by canvas.create oval. And now let's do 300, 300, 400, 400. And yeah, let's just do it. We'll do it black. Okay, so it put it down here. Now, what happens if I did, if I didn't understand how this worked, and I thought, oh, well, I want the width to be 100 and the depth to be 100. Let's try running that. What happened? What happened? Nothing happened. And that's because whoever wrote create oval implemented it differently than create rectangle. And what happens is that oval will not draw itself backwards. Okay, so that tripped me up because I'm used to packages that have the width and the height. So in class, I would ask everybody to draw a rectangle, draw an oval, and then we put them all together. All right. So I also want to show that you can put colors here. And there are a lot of different colors. I'm surprised at all the colors. Like, there's like salmon. Let's try that, salmon. But I'm going to have to change this to be 400, 400. Let's run that. There we go. Salmon. How about that? Okay, so that's basics of graphics. We use create rectangle, create oval. Okay, let's do some of this function stuff. So let's create a function that will be def draw square. Let's just start def square, okay? All right, so let's try canvas.create rectangle at 200, 200 to 300, 300. And then let's call draw square. Now this is not going to work. Think about why is this not going to work? Did you figure it out? Let's try it. Okay, big error. And the error, if I can get it just right. Nope. Syntax error, line 13. Oh, always forgetting my colons. All right, here's a different error. Name canvas is not defined. Why isn't this working? Because I got this canvas here. Why isn't it working here? Well, this is a problem with what we call scoping. So canvas is a variable only available within the function main because we declared it in main. By the way, somebody asked last week, why can we put this canvas height inside main, or does it need to be outside main? It needs to be outside main if you're going to use it in more than one function. If you're going to use it in main or draw square, because you want to give it, quote, global scope. Okay, and some of you may have heard the idea of a global variable and how bad global variables are, and they are very, very bad. The only reason that we do these here as global variables is because we treat them as constants. All right, so how do we solve this problem? What have we learned about today that would allow us to get canvas from here over here? Thoughts? What did we see over here? What was this about? Is this a way that we could get something from this caller here into the function? Because remember, I told you that this declaration here, this variable is now available within that function. What if we could pass in the canvas as a parameter? Let's go take a look. So we're going to take a parameter, and I'm specifically going to call it something different to show you that it is different. So I'm going to call this parameter my canvas, and now I will pass in canvas. And let's try running that. Now it works. Okay, so again, how did this work? It's because we took canvas, which was generated in main, and we passed it in as a parameter here. Now, you may have, if you heard me carefully, you may have heard me say that something that you pass in to a function cannot be modified. Canvas will be the same canvas before and after this function call. But you may have realized that, hey, it's actually sticking this square on the canvas. So this is a subtlety. So canvas as an object was not changed. But canvas did have an operation performed on it. It's a subtle distinction, which is probably too hard to explain now, but just be aware that that is something to think about, and I really encourage people to be curious about these things. All right, so we've figured out how to pass in my canvas and create a rectangle on it. Okay, and now how could we return something here? There's not a really good way to return. There's not really a point to return something, but let's go ahead and just return. Now I'm going to need to use a random. No, let's not use random. Let's just return 5, okay? And then I'm going to print, and I'm just going to print this. Run it. All right, see what came out in the console? 5. Okay, so that's a way to return a value. All right, I think we have covered what we need to know in order to do this problem. Random circles. So again, this week I've got the problems here, and let's open this problem up. It's actually here. Oh, Mars, wait, that's not what we want. Oh, I didn't get the link right. Okay. So this is actually, let me just make sure, but yeah, this is how the assignment comes to you. It's already got all of this stuff. Not only does it import the graphics, import random, it gives you the width, the height, the size, the circles, the number of circles, and the main creating canvas. It also gives you this random color function. I mean, they practically give you the whole thing, right? No, there's still a fair amount to do. The task at hand is to draw 20 random circles with random colors. Okay, it tells you how many circles is 20, so obviously we could change the number of circles. It gives you the size, 20. Obviously we could change that. And actually one of the extensions is to make it a random size and a random number of circles. Well, let's think about this. We got to draw circles. Okay, well, good news. We did an example where we drew a circle. So we know how to do that. They're asking us to draw 20 circles. Do we know how to draw 20 circles? Well, we've got for loops, right? We learned that in the past. So we know how to do that. We can draw 20 circles. How do we draw 20 random circles? Okay, so that's going to involve the random library, which we've already imported up here. And we want to, use problem decomposition. So let's assume that we create a new function here. Let's assume that there's a new function called draw random circle. Let's assume this function already exists to draw a random circle, and then we'll work on implementing it. So we know how to draw a circle, right? That's canvas.draw oval. And then again, we're going to start at, we're supposed to draw them at random positions, but let's just do it. Okay, let's say it's at 100, 100 to 200, 200. Oh, actually, we already know that it's going to be a circle size. So it'll be 100 plus and then we can repeat this Another question is, why is it draw oval and not draw circle? Some packages will give you both, but they wanted to be simplistic, and oval will draw a circle as well as an oval. Similarly, a rectangle will allow you to draw a rectangle or a square, so you just have to do it manually. Let's just try running that. Does that work? Why didn't it work? Interesting. Did it? Oh, we got an error here. If I can scroll up. Canvas has no attribute draw oval. Let's go back to the documentation. Did I goof that up? Oh, it's create oval. Did I tell you need to make 50 mistakes a day before you can learn? Okay, create oval. So, yay, point for us. Let's try drawing 20 of these. And so they give us the number of circles up here. So remember, when we put this in here, n circles, what is I going to be? Think for a second. What is I going to be? Is it going to start at 0 or is it going to start at 1? And is it going to end at n circles or n circles minus 1? It's actually going to go from 0 to n circles minus 1. Well, does that mean we need to add 1? Well, no, because if n circles is 2, it's going to draw a circle for I 0 and for I 1. So those are 2. And if we don't care about the index, then it really doesn't matter. All right, so this should draw 20 circles. Now it's going to draw them all at the same place. So how about I add let's add I. I'm not even sure what this is exactly going to look like. Okay, so because all the circles ended at the same place, it's got this really weird look to it here. We would actually have to draw circle size plus I, circle size plus I. There, that looks a lot more like it. Okay, if we go step, you can see it's drawing these little circles, but they're overlapped with each other. All right, so hey, we figured out how to draw 20 circles. Now let's take this line. Let's put it into here. What happened to my pass? It's actually out there. Okay, let's now call draw a random circle. Now, this is not going to work. Can you figure out why? We've actually seen this one before. Problem is that canvas doesn't exist down here. So we actually have to pass in canvas. Okay, now what's the problem? Traceback circles. Oh my gosh. Canvas is not defined. My canvas. Okay, that's a really terrible error message. All it was supposed to have been saying is that I is undefined. It didn't mention I at all. But yeah, so I copied this code from up here that used I. So once I get rid of the I, now it works fine. All right, but this didn't solve the problem, right? So we created 20 circles at the exact same place. We have to create them at a random place. Okay, so now let's talk about how are we going to create them at a random place. So let's create some variables. We need x equals, I don't know if I can, yeah, okay, it'll let me do that. And then I have to call it left x and top y, and then bottom x and, oh, sorry, right x and top bottom. Okay, we need to figure these out, and then we're going to replace this gobbledygook with left x, top y, right x, bottom y. All right. Now I'm just going to make sure that I've actually transcribed this correctly. So I'll put 100, 100, 150, 150, and just run it. Yeah, okay, so that works. All right, so we need to get a random here. So how does random work? I don't know if it tells me random here. I'm just going to have to remember back to the, so we imported random, so we need to do random dot, right? So when you import random, just like you have to import canvas, you got to use that name, random dot rand int, and now we want to give it a range. So we want it to start from well, okay, there's an extension where it has to fit within the box, but at a first cut, they don't care about that. Just somewhere in the range, right? From 0 to canvas width. So we go 0 to, actually, I think we can just put canvas width. And it'll give us from 0 to canvas width minus 1. Okay, let's try that. Okay. Boy, these error messages they're giving us today are terrible. Random.randint. Is it 0 to canvas width? Okay, did it do it? I think it did it. I think the problem is that it came up with a random number, but it's not, because the right is always 150. And the oval won't draw things that are negative. I think that's probably the problem. Let's just go for it and then see what happens, okay? So this is going to be canvas height. This is going to be, okay, now we need a random width. So ideally what we want to do is have it fit on the frame. But again, I don't think they care about that for the first one. So let's just do the same thing. Well, it has to be plus that, okay? So let's do left x plus that. And this will be top y plus that random. And again, these numbers, this number is not the same. This number that's generated here is not the same as this number generated here. They're going to be different values. Okay, now it's starting to work. Obviously, a lot of these did not fit. We can do some improvement. We can say 0 to canvas width minus left x and height minus bottom y. Sorry, top y. Okay, now they all actually fit within the frame. Now, you notice these are all black. They wanted us to position at random positions with random colors. Okay, so they gave us this thing called random color. So all we have to do is put that in as random color. Let's try running that. Ooh, look at these pretty pictures. So there's also extensions to have a random number of circles, circles of a random, oh, shoot, I actually did the random size. So actually they wanted us to do the circle size, okay? So I already gave you part of it, but let's just say circle size here. Okay, circle size. Okay, let's run these. Oh, I've got an extra paren here. Okay. And you notice there are actually a few of these that are cut off. That's because I didn't do the subtraction from the starting position. Okay, random number of circles, random circle size, and so that all parts are within the canvas. So those are some things that you can work on. I already gave you part of the assignment. But let's review. What did we learn here today? So we learned a bit about imports, and we learned how to create the canvas. We learned how to draw a oval and draw a rectangle. We learned how to pass in canvas as a parameter. And I want to make a side note that this may seem kind of strange, and I guess it is strange, but it's actually quite common in Python and many languages whenever you're dealing with inputs and outputs. Like if you're reading out of a file, you're going to open that file in one place, and then you're going to have subroutines that act on that file, and you're going to need to pass in the object that represents that file. And there's lots of different examples of this. Sometimes you're going to be parsing strings, and you're going to have a string parsing function. You pass it in, and yada yada yada. So this is actually not as odd as it may seem, because the alternative is we could have just done this all in the main function up here, and it actually would have been simpler because we wouldn't have to worry about passing things down. And in a program this simple, that's actually the appropriate thing to do. But we're trying to teach you how to do things for bigger programs. Yeah, so I think that's about it for graphics this week. So good luck on working other problems. And in the past, I've been generating challenge problems for students. I'll think about generating a challenge problem for students for this week as well. Although I'm not sure they're going to be doing more graphics next week, so I don't want to get ahead of myself there. But yeah, good luck this week.